Section 12.4 talks about similar triangles. So in this section, we'll be able to understand similar figures, theorems for determining similarity for figures, properties of proportion for similar triangles, mid-segments of triangles and quadrilaterals, indirect measurements using similar triangles. So let's first talk about similar triangles. And it says triangle ABC is similar to triangle DEF, and this is the little symbol we use for similarity. It's like a little squiggly. It says if and only if the corresponding interior angles are congruent and the lengths of the corresponding sides are proportional. So it says angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Line segment AB over DE is equal to line segment AC over DF is equal to line segment BC over EF. The common ratio of lengths is what we call a scale factor. Okay, we'll talk about this as we go through some examples, guys, so don't worry about it so much right now. Similar polygons. It says two polygons with the same number of vertices are similar if there's a one-to-one correspondence between the vertices of one and the vertices of another, such that the corresponding interior angles are congruent and the corresponding sides are proportional. Okay, so we have some similar triangle theorems. It says if the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. Sine angle side. It says if in two triangles, two sides of one triangle are proportional to their corresponding sides in the other triangle, and the included angles are congruent, and the triangles are similar. And then we have similar triangle theorems, angle-angle similarity. It says if two angles of one triangle are congruent respectively to two angles of a second triangle, then the triangles are similar. And it says for each pair, find a pair of similar triangles. Okay, so a pair of similar triangles, what we would have here would be triangle CBD. This would be one of them. Triangle CBD and triangle CAE. And these two triangles would be similar, right? And let's see. And they just wrote it a little bit. Oh, here we go. CBD, CAE, right? And then they did another one too. They said CDB, right? That one there. And CEA, that one there, right? Okay, so let's take a look-see. Keep going down here. Let's see. Oh, we're going to do the same thing for this one here. Okay, so what triangles are going to be similar? Let's just find a pair. ABC. So triangle ABC is going to be similar to triangle, okay, let's see, EDC. Okay. All right. And it says angles B and D are, angle B and angle D, because they're both right triangles. And also angle ACB and angle ECD because they're vertical angles. Okay, so triangle ACB is congruent to triangle ECD by the angle-angle theorem. All right, so let's take a look here, and it says in the figure solve for x. Okay, so let's say we can't figure this thing out. All right, let me get my pen going here. Sorry guys, it's freezing up. There we go. Okay, so I'm going to look at this, say this triangle right here, okay? And I'm going to write a proportion of the sides. So I'm going to say the fraction or the ratio of x to 8. It's going to be equal to, now I need to figure out how could I write an expression describing this piece here. Well, if we know the whole piece is 12, and we know that from here to here is x, then this piece we could write it as 12 minus x, right? This whole thing minus this part will leave me what's left over, okay? So that's going to be 12 minus x all over its base, which is 5. All right, and now what I'm going to do, I'm going to cross multiply. So we're going to go 5 times x is 5x. 8 times, I'm going to do all of this in parentheses. This is going to be 96 minus 8x. So now I'm going to solve for x by moving the x to both sides. Okay, get rid of those 8x's. That's going to give me a 13x equals 96. And then we'll divide both sides by the number 13. And 13 and 96 don't go into each other at all, guys, and I can't reduce them. So my value of x is just 96 over 13. Okay. All right, so properties of proportion. It says if a line parallel to one side of a triangle intersects the other sides, then it divides those into proportional segments. Okay. So notice how they're writing it here. So they're saying, they're saying the fraction of y to x is going to be equal to the fraction of w to z, right there. Or vice versa, x to y will be z to w, okay? And we can kind of keep playing that game as many times as you want. You can have a whole bunch of parallel lines and we can write lots of proportions, okay? So, let's see. I'm going to kind of skip over to the part to where it's going to get, a little bit more important. So I'm just going to kind of keep scrolling down until I get to the problems that we're going to start working on. Here we go. It says, on a sunny day, a tall tree casts a 40-meter shadow, and at the same time, a meter stick held vertically casts a 2.5-meter shadow. How tall is the tree? Okay, so we have two similar triangles here, guys. This triangle here is similar to this triangle here, okay? And I'm going to set up the proportion by saying, okay, this is the distance we're looking for, and we notice we're calling it x. So I'm going to say x over 40, so the height over the shadow is going to be equal to the height over the shadow of the second one, okay? And now we can cross multiply. Oh, come on, pen. Let's see, here we go. Okay, so 2.5x is equal to 1 times 40, which is 40. Then we'll divide both sides by 2.5. Okay. And let me get my calculator. Let me turn it on. And let me clear that screen. And what's 40 divided by 2.5? And I'm coming up with 16. Okay. So here's the height of the tree. It is 16 meters. Okay. All right. Let's take a look at the next problem. It says, are the given rectangles similar? Tell why or why not. Okay. So there's something we're going to know. If they're similar, then one ratio should be equal to the other one. Okay. So if I look at, say, the small rectangle here, the ratio of 2 to 5.5 should be equal to the ratio of this side to that side. Now this side, notice the numbers that I'm actually adding up. I'm actually adding up 2 and 4, which is 6, and that should be over 16.5. Now I don't know if they're equal. The way we're going to find out, we're going to cross multiply. So we're going to multiply these numbers across. I'm going to write one answer here, I'll write the other answer there, and we'll see if they are in fact equal. So let me take my calculator. 2 times 16.5. That's given me 33. Okay. Let's do that again. Now let's take 5.5 times 6. And if you notice, that's also given me 33. So yes, they are, because corresponding angles are congruent and corresponding sides are proportional. Okay. So there's my answer. Okay. Now, let's take a look at the next problem here. It says, which of the following are always similar? Okay, so let's take a look at part A. Equilateral triangles. Remember what equilateral triangles look like? They look something like this, okay? So these sides could all be 4, 4, 4, and these sides here might all be something like 9, 9, 9, right? And these angles are all going to be 60 degrees, and these angles are all going to be 60 degrees, okay? And they are in fact proportional, right? So this one here for part A, I would say yes. Okay. Let's look at part B, 2 squares. Okay, so here's a square, and here's a little bit of a, looks more like a rectangle. Let's fix that a little bit. And say here's a little bit of a bigger square. I know it still kind of looks rectangle-ish. But let's see, remember, in a square, all the sides are the same. So let's go 2, 2, 2. I'm just making up these numbers, okay? And let's say these are 5, 5, 5, and 5, okay? So remember, the ratio, 2 over 2, is that going to be equal to 5 over 5? Yes, it is. So yes, and my angles are all 90-degree angles. Any 2 rectangles. Okay, so let's draw a rectangle here. Let's say this side is 1, and I don't know, that side, let's say, is 5. Okay. And then, let's say this rectangle is 2, and this rectangle here is 3. Okay. So I would say is 1 over 5 the same thing as 2 over 3. And if I were to cross multiply, that's 3, and that's going to give me 10. So no, they're not. So for part C, I'm going to say no way. Okay. And then part D says, what about 2 rectangles in which one side is twice as long as the other? Okay, so let's move that over a little bit here, and let's draw a rectangle where one side is twice as large as the other. So suppose I say that's 1 and that's 2, whether this is feet or inches or whatever, right? And I say this one is 3 inches and this one is 6 inches, right? Again, look at my ratio. 1 over 2, is that going to be the same thing as 3 over 6? And let's cross multiply. So that's 6, and that's 6, and yes, they are, right? One side has to be twice as large as the other one, because that's what the condition told me, right? For part D, so for part D, we would say yes, also. Okay. All right. So the directions on this next problem say, determine whether the following pair of triangles 1 through 4 are similar. If they are similar, explain why, and find the scale factor. Okay. So we already know here that this angle and that angle is the same, and this angle and this angle is the same. And I shouldn't, there we go. And then we could find this third angle. And that third angle would be the same as that third angle, okay? Because they all have to add up to 180. And if these numbers up here are the same and those numbers right there are the same, then so will these, right? And so since my angles are matching up, and all so far we know is that 5 is corresponding over 9, we would say, yes, they are similar by the angle-angle similarity, okay? And so my scale factor is 5 over 9. Okay? All right. So let's take a look at the next one here. And it says, we're trying to figure out if they are similar. Okay. So let's see if they're similar. So if I take the ratio of 7 to 3, 7 over 3, is that going to be the same as the ratio of 14 over 6? Okay. And again, I can cross multiply. So 3 times 6 is 42. 3 times 14, oops, come on, pen. Come back here. Okay, is also, also 42. So they appear to be, okay. And so let's see, what do we know? We know that we're going to have, so they're going to be similar, and now we're going to figure out why are they similar. So which ones do we have? We have a side, we have an angle, we have a side, and we have another angle. So it couldn't be, here we go, we can say we have, let's see, they are similar, I would say by, let me see, I'm trying to figure out which one it's going to be. It's angle, side, angle. Let me see, angle, 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 side, side, or side, side, side. Let me see which one. Hold on, guys. So guys, I would say this one is also going to be similar by the angle, angle. So I'll click this one here. And my ratio from triangle AB C to EDF. If I were to take one of the, like say 7 over 14, 7 over 14 is going to be 1 over 2. Okay. Let's see. Let's take a look at this next one here, and can we determine if they are similar? Okay, so doing this next one here, let's see. We know that these angles are congruent, and also we have this angle. So look at the two triangles we're looking at. We're looking at triangle ACD. So triangle ACD is sort of the bigger triangle here. Oops. Come on, pen. Sorry about that, guys. Here we go. Angle ACD, or triangle ACD. And then the second triangle we're looking at is ABE, which is this smaller one right here. So we have this angle and this angle here. And so we're going to go again with the angle, okay? And we're looking at the ratio of the big triangle, which is this whole piece right here, which is 4, over the ratio of the smaller triangle, which is that piece right there, which is 3. So we're going to go angle, and my ratio is 4/3. Okay. And let's see. The next one here, we're going to see if we can figure out the same thing. So we're looking at triangle ABE, which is ABE, this triangle right here, compared to triangle DBC, DBC, that triangle there. Okay. So let's see if we can figure out the ratios, okay? So I might say the ratio of 4 over 5 should be equal to the ratio of 6 over 7.5, okay? And we can cross multiply. Oops. Okay, so let me grab my calculator and let's cross multiply. So we're going to take 4 times 7.5, and that's giving me 30. And I know that 5 times 6 is also going to give me 30, so my triangles are similar. And because we're comparing the red triangle to the green triangle, our scale factor is going to be 4 over 6, which I can reduce to 2/3. Okay, and let's see, this is going to be side angle side, because we have these sides here and the angle in the middle, and so our ratio will be 2/3. Okay. All right, so it says, in the following figures, find the measure of sides marked X. Know that the figures are not drawn to scale. Okay, so let's see if we can do that. Here's this little triangle here. So I'm just going to kind of draw it like this over here to the side. This is A, this is B, this is C, this is 3, and this is X. And then let's draw the bigger triangle. This is A, that's D, that's E. This whole piece here will be 6, because I got to add those together. And this whole piece here will be X plus 9. So I'm just going to kind of slide over my notes so that we can see if we can figure this out. Okay, so let's say X over 3 is going to be equal to X plus 9 over 6. And again, we'll cross multiply. So that's 6X equals 3 times, so 3X, 3 times 9 is 27. Let me move my 3X over. So 3X is equal to 27. So when we divide both sides by 3, folks, we come up with X equals 9. Okay. Alrighty. And let's see if we can do the same thing here for this next one. Okay, so let's take a look at our first picture here. We got something that looks kind of like this here. And this is my angle B, and that's my angle C. This is A, C, B, this is X, and this is 5. Okay, so I'm going to draw that same picture over here. Here's this piece here. This one kind of comes down. So all I did is kind of flip that over, guys. This is my point C. Here's my point D. Here's my point F. So DF is 8, and D Why did I put a C? It's not a C. It was an E. And DE was 7, okay? So again, now I can kind of go over here to the side, or you know what, we can do it right here. 5 over x is equal to 7 over 8. So again, I'll cross multiply. 7x equals 5 times 8 is 40. So we'll divide by 7. And folks, we just come up with 40 over 7, okay? Alrighty. So let's see if we can do this next one here. In the directions say, find the values of x and y. Okay? And let me see if we can look at the picture here and see if we can find the values of x and y. All right. So we have our two similar triangles, okay? And so let me write out my first fraction. Okay, so I might say x over 12 is going to correspond to 24 over 18. Okay, and again, we'll just cross multiply here, so that's going to give me 18x is equal to, let me grab my calculator again, what is 12 times 24? 288. Okay, and then we'll divide by 18. So let's take 288 divided by 18, and that's giving me 16. Okay, so let's see, let's come back up here, and so for this part right here, I'll type in 16. Okay, and now let's see if we can find the value of y. Okay, so the value of y. Okay, so let me see if I can kind of just scooch over a little bit here. Well, maybe not that much. Okay. So I'll do this again. So how about if we say 8 over 12 is equal to, 8 over 12 is going to be equal to, let's see, y over 18. Okay, and I'll cross multiply again, so that's 12y equals, let's figure out what is 8 times 18. And that's going to give me 144. So when we divide both sides by 12, we come up with the y is also equal to 12. So there's my answer, 12. Oops, doesn't look like a 12, does it? There we go. Okay. So it says, draw a segment AB and then use a compass straight edge to separate AB into 5 congruent pieces. So the congruent pieces means that I have to have the same measurement, okay? And then 5 obviously means there's going to be 5 of them, okay? So if I look here, and I look at that piece right there and say, okay, well, I know that can't be it because the distance here is more than those. So I know that's not my answer. And then if I look here and say, look, 1, 2, 3, 4, nope, because I want 5 of them, okay? And then 1, 2, 3, 4, 5, that looks pretty good. And 1, 2, 3, 4, 5, 6, nope. So my choice here will be A. Okay. All right. It says the student wants to know how far up the ground the top of a leaning flagpole is. At high noon, when the sun is almost directly overhead, the shadow cast by the pole is 6 feet long. The student holds a plumb bob with a string 3 feet long to the flagpole and determines the point of the plumb bob touches the ground 15 inches from the base of the flagpole. Let's see, how far up the ground is the top of the pole? Okay, so what we want to do, we're going to do our similar triangle business, okay? And we're trying to figure out this height right here, okay? First thing I want you to notice, do you see how this is given to me in inches, but this is given to us in feet, and this is also in feet? We need to convert everything, and we're going to convert everything to inches. And you might say, well, how do you know you're going to convert it to inches and not to feet? Because this part right here tells me to round to the nearest inch, okay? So I'll tell you what, let's do this. We already know that those pieces here, we already know that this one here is in inches, okay? So 6 feet. Remember, if 1 foot is equal to 12 inches, then 6 feet, 6 times 12 would be 72. So I'm going to put 72 inches here, okay? And then 3 feet would be 3 times 12 is 36 inches. So I'm going to change this to a 36 inches. Okay. So now let's go ahead and do our ratio. So we're going to say the ratio of 36 to 15 is going to be equal to the ratio, why don't we call this x, because we don't know what it is, x over 72. And now we can again cross multiply. So 15 times x is a 15x. And let's take our calculator to figure out what is 36 times 72. I don't know, a big number. Te dije. 2592. Okay. And then we're going to divide both sides by 15. Okay. So divided by 15. Okay. And I want you to notice that we're coming up with 172.8. Okay. So right here I'm going to write 172.8 inches. Okay. And the directions tell me to round to the nearest inch. So they're just asking me to round to the nearest whole number. So the nearest whole number would be 173, right? Alrighty. So let me scroll down a little bit more, and let's see if we can figure out this next problem. And it says, find the distance d across the river. Assume the triangles are similar, and the ratio of d to 100 feet is the same as the ratio of 180 feet to 30 feet. Okay, so let's do it like this. We're going to write one ratio equals another. So d is to 100 as 180 is to 30. Okay. And again, I'll just cross multiply. 30d equals, let's take our calculator, let me move it over this way. What's 100 times 180? Another big number, 18,000. And then we'll divide everything by 30. And divided by 30 is 600. And there's the distance, 600 feet, right? And then right here, guys, I would just type in 600. Okay. Good. Let's keep moving down here. And it says, if you took cross sections of a typical ice cream cone, parallel to the circular opening where the ice cream is usually packed, explain whether the cross sections would be similar. Okay, so let's think about an ice cream cone, okay? And kind of like the old school ones, like a raspa, okay, like that. And it says now we're going to take cross sections parallel to the circular opening. So we're going to take a look, and we kind of like cut this paper thin, right, like that. And we would say, what would we have? Wouldn't we have little circles, right? And so all the cross sections would be circles. And since they would have the same shape, they would be similar. Okay. Alrighty. And it says triangle ABC is similar to triangle DEF, with a side of triangle ABC that is 78% of the corresponding side in triangle DEF. Also, triangle GHI is similar to triangle DEF, with a side of the triangle GHI that is 49% of its corresponding side in triangle DEF. So are triangles ABC similar to each other? Why and why not? Okay, so we're trying to figure out if triangle ABC is similar to triangle GHI. Okay, so let's see. Let me get my pen going. Oops. Come on. There we go. Okay. Okay, so let's see if we can draw a picture. Triangle ABC. So let's go like this. A, B, B, and C. Okay, so we'll call this side A, or that point A, B, and C. And that's going to be similar to triangle DEF. So I'm going to kind of move my notes over a little bit. Right here. Let's go D, E, F. Something like that. Okay. Here's DEF. And it says a side of ABC that's 78% of the side of DEF. Okay, so suppose this, I'm going to just say this side here is X. Then this side would be 78%. Come on, pen. Sorry, guys. 78% of X. Okay. And it says triangle GHI is similar to triangle DEF. So I'm going to draw another triangle GHI, that's going to be similar to the triangle DEF. And it says that one of the sides of GHI is 49% to the corresponding side in this one, in DEF. So this side is going to be 49% of X. Okay, so we know that these two triangles are similar, and we know that these two triangles are similar, and so now it's asking, would these two triangles be similar? Yes, they would. So number one, they would be similar, right? And they'd be similar by all the similarity theorems, okay? And then now it says, write the ratio of corresponding sides of triangle ABC to GHI. So ABC to GHI. So it would be 78 over 49. 78 over 49, okay? All right, and I think we got just a couple more problems here. And it says, these triangles are similar, find the missing length. Okay, so again, let's see if we can figure this out. So I'm going to write one fraction equals another fraction. So how about if we say x over 8 is equal to 3 over 4, and we cross multiply, so that's 4x equals 24. So x should be 6, and so there would be my answer. And looks like we got another one like this, a couple more at least. Let's find the missing length, okay? So one fraction equals another one. So again, how about if I just say 18 over x is equal to 14 over 28, cross multiply, 14x equals, let me take my calculator, and what is 18 times 28? Coming up with 504. So we can divide both sides now by 14. And take my calculator, let's divide it by 14. And I'm coming up with 36. And so A would be my answer. And let's see, we got another one here. Okay, let's see if we can do this one. It says the two triangles are similar. Find the missing length. Okie dokie, we can do that. Come on, pen. Sorry guys, this pen keeps freezing up on me. There we go. Okay, so let's say 2 over 4 is equal to x over 10. Come on. Sorry guys. Over 10, so again, let's cross multiply, so 4x equals 20. So I can divide both sides by 4, and I'm coming up with x is 5. And so there's my answer here. And here we go. Here's the last problem. It says, a lookout tower, here's my tower, casts a shadow that's 150 feet long. Okay. And then we have a truck that is 9 feet tall. There we go. 9 feet tall. And its shadow is 18 feet long. We want to find the height of the tower. Okay. So x over 150 equals 9 over 18. Cross multiply, that's an 18x equals, let me take my calculator again, what is 150 times 9, oops, times 9, that's 1350. And then we'll divide both sides by 18. And divide it by 18. and I'm coming up with 75. And there's our answer. And that right there, y'all, is 12.4.